Okay, now this is a second question in gravitational potential energy. A rocket is launched straight up from the surface of the Earth. It reaches a maximum height from the surface of the Earth at about 4 times radius of Earth. Calculate the initial velocity of the rocket. Okay, so you can see this is the rocket comes from the surface and then it goes to a maximum height, which is 4 times the radius of Earth. So it has two locations. Okay, I have drawn here. You can see here the rocket initially at the surface. It launched upward with certain velocity until it goes to the maximum height when velocity becomes 0. Okay, so he says the height is actually 4 times the radius of Earth. That means the height is 4 times radius of Earth. Okay, so to find the initial velocity of the rocket. So this is actually about conservation of energy. Okay, conservation of energy. Initially, at the Earth's surface, it is launched with initial velocity, meaning that initially the rocket has kinetic energy. Kinetic energy. So as it goes upward, the kinetic energy is changing to potential energy. Until all the kinetic energy change to potential energy. When no more kinetic energy, it is at the maximum height. Velocity is 0. No more kinetic energy. Okay, all change to potential energy. So we use principle of conservation of energy to do this question. Means change of kinetic energy becomes the potential energy. So this is the initial kinetic energy, half mv squared, equal to the change in potential energy. Or find the potential energy minus the initial potential energy. The potential energy formula is negative gmm over r. Okay, now we apply all this information. Okay, so okay, let's write down the formula. Half mv square equal to negative gmm over r final minus negative gmm over r initial. Okay, and as we can see, this is let's identify all these masses. This should be the mass of rocket. Yeah, this is the mass of rocket. A mass of rocket, mass of rocket. Actually, we can cut off this mass of rocket. Yeah, the common we can cut off, mass of rocket. And the big mass is, of course, the mass of Earth. Okay, and this is the mass of Earth. The mass of Earth. This is the mass of Earth. Okay, now, oh, I don't have the mass of Earth. See? It didn't provide us the mass of Earth, but it gives us the gravity of Earth's surface, 9.81. G is a symbol of the gravitational field strength on the surface. Okay, so in that case, I don't have the mass of Earth. I cannot continue. So I need to make use of the G surface. So which is this one. Okay. So let's assume the object on the surface. So the gravitational field strength A, yeah, Ag, is equal to G. Yeah, and the gravity on the surface is G. Okay, so at the surface, A is actually gm over r square. So on the surface, the radius is actually radius of Earth, because on the surface, the distance to the center is radius of Earth, and the gravity is G. The gravity is G. So let's substitute this information. A become G when it is radius of Earth on the surface. Okay, and of course this is a mass of Earth. Okay, because it is the Earth who provide the gravity. So now we can get so cross multiply Yeah, cross multiply. So we got gm equal to gr square. Okay, gm equal to gr square. Yes, that's right. Okay, so we got this. So now we can substitute the gm become gre square. Can substitute to here. Okay. Before that, I need to identify what is the R final and R initial. Okay. You see, R final and I need to rearrange this first because this negative negative. I pick positive. Okay, make never mind. So let us rearrange everything. Negative 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 become positive. So I put in front GM E over RI negative minus, yeah, this one go behind, GME over R final. Okay, now negative negative become positive. Now GME is GRE square, and then okay, and then RI, this is the initial position. How far is it? How far is rocket from the center? Yeah, from the center of Earth. So it's R radius of Earth. Okay. So and also substitute the GM with GRE square. Substitute with GRE square, and below RE is radius of Earth. Initial position. And then here also GRE square, R final. R final finally is from here to the center. How far is it? It is radius of Earth plus the altitude, which is 4 radius of Earth. So total is from here up to here, radius of Earth plus 4 radius of Earth is 5 radius of Earth. Okay. So then we can cut off the radius of Earth. So and then we can factorize out the GRE. You see, factorize out the GRE. So what do we get? Half V square equal to GRE, and then what's left? 1 minus, and then GRE factor out, so this is only 1 over 5. Okay, so after that, what do we get? Half V square is equal to 4 over 5 GRE. And then so V, we can find V, 1 over 4 over 5. This is a 9 point, it gives us the G is 9.81. 9.81, radius of Earth is 6.4 exponent 6. 6.4 exponent 6. And then multiply 2, because from here 2, and then square root the whole thing. Square root the whole thing because of the square here. So the speed finally we get 1.0022 exponent 4 meter per second, or it is actually 10 kilometer per second. You see, in 1 second it traveled 10 kilometer. That is so fast. Yeah, the rocket. So this is the answer. Okay, is it correct? Yes. All right. So I hope you enjoy the videos. Stay tuned for the upcoming videos. Thank you. Bye bye.